the world that we live right now is in analog, but we always use some devices that in the form of digital system. So anyway, you need to learn this related to the digital world. So I see the syllabus in my daughter syllabus on computer in Form 1. So I was shocked that in the Form 1 already they have learned about the basic of digital system. So that's mean they already learn about the binary, the basic 8 decimal number, apa namanya, basis of 8 number, and so on. So maybe that one is just a introduction part of computer system for the Form 1 syllabus. But here, what you will learn also, I think at the early part will be the same as the Form 1 students, for your information. Okay, so I'm not sure, maybe some part of it you have learned at the early stage of this lecture, this course, you have learned about it. Okay, yesterday I have touched, we have some discussion on the analog and digital systems. What is analog and what is digital? What example of analog and digital system? And the world that we staying right now is in the analog form. Okay, let's start with some basic about the digital systems. So digital system, what you are using right now, what you see, what you are using right now is always using the binary digit. So in the matrix world, so I believe you already seen the movie of matrix 1, 2, 3, ada ke 3, ada ke 4. Okay, so it's you are the movie itself using the 1 and 0. So this is called the binary digital system. So where it come from? It's come from representative of voltage, where you or yourself set the value of the certain voltage range to the binary 0, which is low, or binary 1 is high. For example here, okay, so you set 0 to 0.8 volt to a binary 0, 2 volt to 5 volt to binary 1. Okay, so you yourself able to set the certain range, and which range is undefined, normally in the middle of the voltage. Okay, so this digital waveform is 1010. Okay, they are always changing between the high and low. For example, here from low to high, so we have the what we call the rising or leading edge, or from high to low, we call this as a falling or trailing edge. And for the negative going pulse, so you have the falling first and then rising later. So this is the difference between the positive or active high, and this one is for the active low. So the digital waveform, the 1010, you need to know about the properties. One of the properties is the periodic, which is mean that the signal keep repeating after a period of time. Within, for example, 2 seconds, so it is repeating the same waveform. For here, for example, here 10, then 10 again. After 2 seconds, another 2 seconds is another 10. For non-periodic, So it doesn't have a period. So that's mean the signal is not repeating. Okay. For example, here after 2 seconds, so another 2 seconds is not the same form that previously happened. So you have learned about from this. You have learned maybe about the what is the period, time, or frequency. So you have may learned it during the first year in mathematics. So the definition of frequency is the rate at which the pulse waveform repeat itself. So normally it will measure in cycle per second, or what you call the hertz. So hertz or frequency is 1 over t, where t is the period, okay, of the cycle. So the definition is the time, the age of one pulse to corresponding age of the next pulse. For example, here, if you have the clock frequency of 100 hertz, okay, so you have the time period of t equivalent to 1 over f. So you will have a one time period here is 10 millisecond. So this one time period is time 10 millisecond. It's just an example. So this one is very easy one. So this is just an introduction part. Another terms is a pulse width, TW. So TW is considered in the middle between the rise and fall time. Okay, so this is the measurement of the pulse width. So rise time, time for a pulse to go from low to high, and fall time, high to low. So this definition basically, yeah, maybe some start of the class is just an introduction. Maybe could be asked during tests. In the yes or no question. So beside time period, you have also what we call the duty cycle. So the duty cycle is the fraction of time that system is in an active state. That means it operates. So normally it's in the percentage. For example, it active here in the TW of times only. Okay, so within the total time period. So that's mean you need to have a TW over T times 100% in order to have how many percent the data is in active state. So that means in the case it's in the high or position, so representing 10% of the total time period. So while I'm teaching, while I'm giving lecture, so you can, yeah, you can disturb me, you can raise your hand. Because when I open the PowerPoint in the full screen, I cannot see you. Okay, so right now I only can see you. So another important part is the timing diagram. What is a timing diagram? It's a graph or digital waveform showing the actual time relationship of two or more waveforms and how each waveform change in relation to the others. Okay, so we have a clock, we have a signal A, signal B, and signal C. So maybe signal C is depends on the input of A and B. Okay, so maybe when A and B change, C could change or C could maintain. So this example of a timing diagram. So when you use some components later on, maybe some basic gates, and or and so on, so you will see this. So in digital system, the emphasis usually the timing, not the amplitude. because amplitude to represent a bit is predefined. So the timing when the change happen is important, because we only have 2 bits, 1 or 0. So normally it's already predefined value of the amplitude. Okay, so see in the slide, just a simple exercise. Predict digital waveform has a pulse width of 35 milliseconds and period predict of 150 microseconds. So determine the frequency and duty cycle. So the frequency is 1 over T. So the T is 150 microsecond. Okay, then the duty cycle is 25 microsecond over 150 microsecond times 100%. So then you get the frequency and duty cycles. Dah beda. Okay. For the first part, introduction. So here, from this first module, so you have learned what is digital, what is analog, along with some examples that you have put in the Google form yesterday. So you should be able to differentiate between the analog and digital. Give example of analog and digital system. Advantages of digital system compared to analog system. Okay, in the test also some question will be asked, maybe what is the advantage of using the digital system, for example. You can calculate the frequency, the period, the duty cycles. So